Hello, and welcome to this lesson on flip-flops. Now, in the previous lesson, we talked about latches, which were the fundamental digital circuit structure that let us store information. Flip-flops are constructed of latches, and we'll use those as the primary circuit for storing bits of information in our digital circuits. So, let's jump right in. There are a bunch of different types of flip-flops, but the one we will talk about here in this lesson is called the DFlip Flop. Now, the DFlip Flop consists of two latches. The first one is the D latch, which, as you remember, has input D, and input C for control, an output Q for set, and an output Q naught for reset. It also has another latch, the SCR latch. Now, if you haven't watched the videos on latches where we talk about what goes on the inside and how these latches behave, please go and check that out. But these are the two latches we'll use in the D flip-flop. The SCR latch, as you remember, has an input for S, an input for control, an input for reset, and also an output Q and an output Q naught. Now, the outputs Q and Q naught from the SCR latch will be the actual outputs Q and Q naught for the flip-flop. The Q outputs from the D latch will connect to the S and the R signal. And on the input side, there's an input signal D. That is the bit that we want to store, connects to the D input. And then we have a signal C. Now, what makes it special is that input C that goes to the D latch also feeds around towards the SCR latch, but not before being passed through an inverter and connected to C for the SCR latch. So let's go ahead and explore the behavior of this circuit by taking a look at its truth table as we change the input variables. We'll have on the input side C and D, and on the output side are Q for set and Q naught for reset. Let's just go ahead and say we have a 1 and a 1 on inputs C and D. That puts a 1 on the C input to the D latch and a 1 on the D input of the D latch. Now, we know from the previous lesson that this input vector produces the set output 1, 0 on the output of the D latch. And that 1 and 0 become 1 and 0 and 0 on the S and R inputs of the SCR latch. But C is equal to 1, and after it passes through this inverter, that means there's a 0 on the C input for the SCR latch, which puts the SCR latch in its no change condition. So that means that the outputs at this point in time are undefined. We actually don't know what those outputs are. So let's push things forward. Let's now go to 0, 1. So a 0 on C and a 1 still on D. We'll erase some things to clean it up a little bit. So we still have a 1 on D and we have a 0 on C. So that means that the D latch is now in its no change condition, which means that the 1 and 0 will stay on the outputs of the D latch. So the SCR latch will still have a 1 and a 0 on its inputs. But now that the C input is equal to 0, after going through the inverter, it's equal to 1. So there's a 1 on the C input to the SCR latch. That puts it in its update condition. So that means that the set reset goes 1, 0 on the output. So Q and Q naught are now defined as 1 and 0. Notice that change happened when we took C from 1 to 0. Now let's go and do 0, 0 on C and D. So if we have 0, 0, that means that the D latch is still in its no change condition, which means that the outputs are still 1 and 0. Because C is 0, that means the inverted output to the SCR latch is still 1, which means that nothing changes, and the output remains at 1 and 0. There was no change. So let's do this now. Let's go 0, well, let's go not 0. Let's go 1, 0 on the D latch. So that'll put a 1 at C and a 0 at D. Now the 1 at the C input of the D latch means that the circuit is in its update condition, which means that the 0 causes it to go to reset. So 0 and 1. So now there's a 0 and a 1 at S and R respectively. Now the 1 at C means that the C for the SCR latch is at 0, and so the SCR latch is now in its don't change condition. So the outputs actually stay the same at 1 and 0. So even though we've changed the clock from 0 to 1, it still doesn't change. Now, when we take the D latch, and let's finally put the input at, let's just go to 0, 0. So that's 0 on C and a 0 on D. The 0 on Z means no change, so the output remains 0 and 1, which means the input S and R have 0 and 1. But the C equals 0 means the input C to the SCR latch is now equal to 1, and the circuit can update, or this latch can update, and that puts it in its reset state. 0 and 1 and on S and R gives us 0 and 1 on Q and Q naught. So 0 and 1. Again, notice that the change happened when the C input on the D latch went from 1 to 0. That makes this D flip-flop a negative or falling edge triggered D flip-flop. So the trigger is whenever there's a falling edge on C, the control, when C goes from 1 to 0, at that moment, whatever D was gets deposited into Q, right? So at this falling edge from 1 to 0, the 1 at D went to Q. On this second time it happened, the falling edge of C, the value that was in D went to Q, and obviously the Q naught stays as the inverse of whatever Q is. So basically, D is the bit we want to store, Q is the stored bit, and the update happens on the falling edge of the control signal, whenever the control signal goes from 1 to 0. So that's a negative edge triggered D flip-flop. Very quickly, let's talk about a positive or rising edge triggered D flip-flop. The structure is exactly the same. We'll have our D latch and our SCR latch. So Q and Q naught, which feeds S and R. We still have control. We still have outputs Q and Q naught. Everything stays basically the same. We have input D. The only thing that changes is what we do for C, right? Since we before had it set up where we would trigger on the negative edge, we want to trigger now on the positive edge. All we have to do to accomplish that is just flip over the C right at the very beginning. So we invert C right off the bat. That puts it into a state that's going to give us a positive edge triggered D flip-flop. So this flip-flop will behave exactly the same as the one we just looked at, except here now the outputs will appear, the bit will get stored on a C going from 0 to 1, as opposed to C going from 1 to 0 in the previous example. But other than that, this flip-flop behaves exactly the same. As always, if you have any questions or comments or concerns, please let me know. And if not, I'll see you guys in the next lesson. Thank you.